Okay, as promised, here's the second video on how to do partial fraction decomposition. This is problem number 24. So page 501, number 24 in the textbook. Okay, actually it's an integral and I stole it from that. So all I'm going to do is break it apart. You ready? So it's the same method. We take the denominator. I don't care really about the numerator. In fact, the numerator looks like it factors, actually it doesn't. But the denominator, you want to take out the x and look what you have left behind. You've got an x squared plus 3. Okay? So x squared plus 3 doesn't factor, man. That is a sum of squares, and the only factors are like imaginary numbers, right? Complex numbers. Imaginary. So who cares? What we're going to do is we're going to break this apart as a fraction over x plus another fraction over x squared plus 3. Okay? Now there's a rule you have to worry over, okay? Over linear factors where there's an x there, that's degree 1, so above it is 1 less, and it's going to be a constant, a. However, above this guy, this is what they call an irreducible quadratic. It sounds like a foreign language, and it kind of is. It's from long ago. It's an irreducible quadratic. It's got a square to it, so what goes above it is 1 degree less, which is possibly, well, that means we're going to have an x and a constant. Possibly. That's what the partial fraction thing does. Is there could be an x, there could be a constant. I don't know. We'll find out. So what we do is we write bx as in a different coefficient, and then possibly a plus c as well. Okay. Now, I don't know how you are with clearing those fractions, but what happens is you come along and you multiply by x and x plus 3, x squared plus 3, I should say. Okay. And it hits here, and here, and here, and you're going to be clearing fractions. So I save a little bit of ink, and I do that kind of mentally. What happens is it clears the entire denominator on the left. Okay, gone. And then the next, on the other side, when you hit the a over x, you'll lose an x, but you still have a multiplying with x squared plus 3. And when it hits the last fraction, which is the bx plus c, it's going to lose the x squared plus c, but it still has or retains the x. So we have plus bx plus c times x. The goal is to, again, the goal is to find a, b, and c, okay? Now, you could multiply through, but I'm going to remember that cute little shortcut. You ready? What I'm going to do is I'm going to look at my factors, and I see this lone little x there, and I go, hey man, what if x is 0? And that's what I do to make that guy disappear. Let x equal 0. It has to satisfy all x's, including 0. So when you plug in 0, of course you get 0 squared minus 0 plus 6, which is really just 6 on the left-hand side. And on the right-hand side, you've got a times 0 squared plus 3, and then plus bx plus c, but guess what? Times 0. Bye-bye, right? It's gone. And what you have simply is 3a on the right, 6 on the left. Stand up, sit down. We know what a is. It's equal to 2. Yay! But that's all you can do with that method. Boo! That's a bummer, because you cannot dream up a number for x to make the x squared plus 3 turn to 0. Actually, you could. How about the square root of 3 times I? No, we're not going imaginary numbers today. So we're stuck with this. What happens when you're dealing with these irreducibles is now you're going to have to multiply stuff out. So I'm going to go end run here and write x squared minus x plus 6 is equal to a. I'm going to distribute the a. X squared plus 3a. If I'm doing, make sure you're doing it right. And now in this case, pretty simple. Sometimes it's a FOIL, okay? But this case, it's just x multiplied. So, okay, we do it, and we go plus bx squared plus cx. But I forgot something. We know what a is. I should have put him in, but I'll put him in now. we found out that a is 2. So we've got 2x squared plus 3 times 2 is 6 plus bx squared plus cx. And this is what we're staring at now. Okay, we're still on a mission. We're trying to find b, we're trying to find c. And it's this case where you actually will compare the coefficients like I did in the previous video. This time we have an x squared. How many x squareds do we have? 1. And on the other side, I have 2 of them. Oh, wait, plus b. Okay, so this system is saying 1 is equal to 2 plus b. Oh, that's nice. B plus 2 has to be 1. So what is b really? B is -1. Hurrah! That was easy. Okay, let's go with maybe the x's. And I'm just going in order of powers. I don't care. With the x's, on the left-hand side, I have a -1. And on the right-hand side, look for the x's. Oh, there he is. Just c. So c is -1. They're both -1, it turns out. And if you went with the constants, if you check, 6 equals 6, do you see that? 6 equals 6. The polynomials are matching, and for them to match, the a's and b's and c's have now been determined. So guess what? Now you can write your breakout thing. What we've got is x squared, your decomposition, minus x plus 6 all over x cubed plus 3x is equal to a, you can't see this, can you? Okay, is equal to a, which is 2. So 2 over x plus, and then I remember b and c are negative, so -1. So -x, -1 all over, what was the denominator there? Yeah, it's x squared plus 3. Now you can pretty it up and say maybe, how about we write it as 2 over x, notice it's bugging me, 2 over x minus x plus 1 maybe over x squared plus 3. Better looking, they're both A's, and wonderful, well, A's in algebra 1 or 2. We parsed, actually it's more like college algebra and pre-calculus that you're doing stuff like this, I forgot. So it's higher level algebra, but we did it. We used systems in this case to solve for the A's and B's and C's, and that's how this fraction breaks apart. Now imagine integrating our results, because that's what we're going to do next in the next video. I will show you how that's done. I can't wait.